a massive group of galaxy clusters. The picture was announced during a NASA preview event attended by the US President Joe Biden and Vice President Kamala Harris. NASA says its first images have targeted distant galaxies, bright nebulae, and a faraway giant gas planet. That is really quite amazing, isn't it? Well, we can now speak to the astronomer and astrophysicist, Jonathan McDowell. Great to get you on the program, Jonathan. And I'm sure many of our viewers, as I am myself, extremely excited about the sorts of images that we're seeing there. Just talk us through how significant this is for people in your field and for NASA as well.
Well, this has been a long time coming. I first went to a planning conference for this telescope in 1989. So to finally get the science now, we're all really excited. And so, we've learned a lot about the universe from Hubble. JWST is going to see further. It's going to see in more detail. For this first image we saw lets us see the early universe, baby galaxies at great distances from us in the same level of detail that Hubble saw nearby galaxies. And so we get to compare how the universe evolves over time. But these first images that are coming out tomorrow are very, very different kinds of objects, much the big planet, much nearer to us, nebulae, and it's really going to display how JWST this telescope is going to be a Swiss Army knife, like Hubble has been, to attack all kinds of different science problems that we've been waiting to get our teeth into for a very long time.
That's fascinating, and I really love the description, the analogy of that Swiss Army knife, Jonathan. Just talk us through what NASA is hoping to be able to do with these images and this sort of information.
Right, and I want to make clear, it's not just NASA, it's also the European Space Agency, which is a partner in this, and the Canadians. It's an international project. Astronomers all over the world are going to use this. And so, yeah, we want to see, how was the universe different way back in its history? How did we get to be where we are now? And then with studying the atmospheres of planets, in the past 20 years, we've discovered thousands of planets around other stars. That's been a huge discovery, but we don't know what their atmospheres are made of. This telescope is going to let us probe what elements are in the atmospheres of these planets. And we're going to be able to study the motions of nebulae, the evolution of stars, and so really just get a much deeper understanding of how stars are born, live, and die.
And Jonathan, just briefly, as we're running out of time, sadly, but what are you hoping one of those discoveries might be? What's something that you've been thinking about for a while?
Well, I'm really interested in the role that supermassive black holes, billions of times the mass of the sun, play in the lives of galaxies. And so with the sharp imaging of the JWST telescope, we're going to be able to measure the motions of stars around those black holes and measure their masses. So that's one of the things I'm looking forward to.
Fascinating stuff. Jonathan Christopher McDowell, thank you so much for joining us on the program with your thoughts on that story.
Thank you.
It's quite something, isn't it?
Expanded. The first image from NASA's new space telescope was unveiled today. U.S. President Joe Biden was on hand to release the image taken by the James Webb Space Telescope. The image is the farthest humanity has ever seen in both time and distance. The telescope rocketed away last December from South America and reached its lookout point 1.6 million kilometers from Earth in January. The plan is to use the telescope to peer back so far that scientists will get a glimpse of the early days of the universe over 13 billion years ago. Does that not just blow your mind? For more on this, I want to bring in Lamiya Mowla. She's an astronomer at the University of Toronto's Dunlap Institute for Astronomy and Astrophysics and joins us from Halifax. So Lamiya, welcome to the Rundown. Last hour, President Joe Biden released this image from the James Webb Space Telescope. What did you think when you saw it?
We were all absolutely blown away. We are here with the Canadian team at Halifax, and we were all waiting for so long for this image, to see these images, not just since the launch in December, but for the last decades since this telescope was being built, and now that we see this image, and it's more beautiful than we imagined it would have been, and we just can't wait to start analyzing this data.
All right, so you can't wait to start analyzing, but when we look at this image, can you describe what we're looking at and what intrigues you or what surprises you from what you saw?
Yeah, of course. So what you're looking at is a very, very, very tiny part of the sky. So just to give you an example of what size of the sky you're looking at, it's if you hold a grain of sand in your hand and you hold it at an arm's length, that's the size of the sky that you're looking at. So it's like a pinpoint on the sky, and you can see thousands of galaxies in just this small pinpoint of the sky. So all these small objects that you see in the image, all the orange and blue and white objects that you see, are all individual galaxies. And these are galaxies not as they are now, but as they were billions of years ago, because the light, they travel at the same speed, at a constant speed, and the time it takes, the further away the galaxy is from us, the longer it takes for that photon, that light, to come from the galaxy to us. So what you can see here, this light has left the galaxy from anywhere between a billion years ago or 4 billion years ago to all the way to 13 billion years ago, just right after the Big Bang. Our universe is about 13.7 billion years old. And what you can see here are some of the first galaxies that were born in the universe.
Wow. I mean, that's just incredible to hear you describe it. It's sort of hard to get your head around it, just thinking about how it's from billions of years ago, and this isn't what exists today. But what could this teach us about the beginnings of our universe?
So what we are seeing here is we are seeing these different galaxies at different snapshots in time. Like I said, that these are because the light is traveling at the same speed, and you're looking at galaxies, images of galaxies at different snapshots in time. So some galaxies, you're looking at them 13 billion years ago, some are 12 billion years ago, some are 11 billion years ago. So what we astronomers do is that we study all these different galaxies, and then we try to piece together a picture of how all these galaxies could have aged over time and how they could have grown up. So it's like taking a video of your child or an image of your child, every day for the first 10 years of their life. And then as you look through the images, you can tell how a child grows up. And that's how we almost piece together how galaxies grow up. We take these images of different galaxies at different snapshots in time, and then we try to understand how they could have changed from this one time period to another. And that's how we try to understand how a galaxy such as the one, our Milky Way, where we live, how it could have formed.
That is just amazing to hear you describe it. But just finally and quickly before we go, Canada has played a significant role in all of this. Can you briefly tell us about that?
Absolutely. So the James Webb Space Telescope is a joint mission of NASA, the Canadian Space Agency, and the European Space Agency. And Canada in particular has built one of the 4 instruments that are on board the James Webb Space Telescope, the Near Infrared Imager and Slitless Spectrograph, NIRISS. Canada has also built the fine guiding sensor of the telescope, and that's the sensor that is needed to keep the telescope steady and pointed at one point of the sky. So this image that you're seeing, this crisp image, this is made possible because the fine guiding sensor that's made by Canada is holding it in place absolutely steady this whole 2 hour time that it's taking this image.
Sounds like a pretty important job. All right, Lamiya, appreciate this very much. Thank you so much. Lamiya Mowla is an astronomer at the University of Toronto's Dunlap Institute for Astronomy and Astrophysics, joining us live from Halifax. Thank you.